Good morning, everyone. It is Tuesday, June 13th, and you have found yourself at the final and grandest, I think, webinar in the code series today, lighting and electrical. My name is Katie. I work at the Lighting Design Lab, and I will be kind of behind the scenes, really actually behind the scenes, monitoring for questions. And let's go to the next slide. So we've got a few little housekeeping things. If you have not attended a webinar with us before, you may be surprised to find yourself on mute. You're going to be on mute the whole time, but we accept questions, any and all questions, at any time. Find the little chat function in whatever version of GoToWebinar you're using, whether the web or the desktop app. And in the chat, you can type your question. It will show up on our end, and we will answer that for you at the right time. Additionally, this time we got the handout ahead of time because Shaun is on top of things. If you find the handout feature in your GoToWebinar, you can download that right now and follow along if you'd like. It'll also be available on our website within a week or so after this presentation, which is being recorded as well. So there'll be a video of this as well. What else did I miss on there? Oh, there's our email address if you have any questions, and there's a short survey at the end. I'll talk about that at the end. And thank you again to Seattle Department of Construction and Inspections and Duane specifically for partnering with us on this. And we got Shaun back and his company SPD Light Studio. If you have not heard, that's Shaun's company now. And Lighting Design Lab is powered by Seattle City Light. I'm a City Light employee. Next slide is maybe the start.
Yep.
Okay, take it away, Duane. Thanks, everyone.
Everybody, I presume at this point already knows me, and by the webinar number 5 getting pretty tired of me, but here I am again, and looking forward to this next webinar. And our special guest today is Shaun. You want to tell us who you are, Shaun?
Hey everybody, good morning. Interestingly enough, I notice in the attendees that there are a whole bunch of people that I don't know, which is a relative rarity for me. So, I'm Shaun Darragh. I am a lighting designer. I've been a captive of the lighting industry for the last 35 years, which is kind of horrifying. Most recently, I have kind of spun myself around to being a lighting educator, including with SPD Light Studio, since leaving the Lighting Design Lab back in August. So glad to be asked back to be Duane's straight man or color commentator. I'm not sure which.
Okay. I think actually what it is the good cop, bad cop thing, and you know who the bad cop is. This is a slide that I hope you've all seen before, that we, instead of like most places who are saying, well, should we make progress this year or not, have legislated goals that were to hit some very aggressive targets over the next several years and the next couple decades. And if anything, over time, these new legislation comes along at the state and city level and says, actually, we want to go a little faster than that. And you want to just like say something about LED here as an example, Shaun?
Sure. So it'll come as no surprise to anybody who's had anything to do with design or construction or energy codes over the last 30 years that lighting has been kind of the workhorse for how we have saved energy over this time. And a big part of that driver, you know, as we've gone with technological upgrades from incandescent to fluorescent to compact fluorescent to ceramic metal halide. Now we're into LED, the LED world, right? And we've been here honestly since about 2000, but from a commercial standpoint, from about 2010, 2015 or so. And what we're finding is that LEDs, of course, as we understand, become more efficacious over time. At a certain point, we're going to kind of run out of that. But the good news is that lighting is now really using so little energy in the buildings. And this is kind of just giving us that idea of some of the opportunities. So then, next slide, Duane.
Before we go, is that accurate on the upper right there, that right now warm white LEDs should be crossing into the 200 lumens per watt?
I got to tell you, I always take these charts with a grain of salt, because those tend to be laboratory conditions, not necessarily in real life conditions, and they tend to be bare lamp, not in luminaires. So I didn't source this chart, so I'm honestly not sure of its provenance.
Okay. It's
I mean, I see it comes from energy.gov, but what I mean is I haven't read what it's actually it's actually telling us. However, what a lot of that really starts to point to, you saw that the trending of adding efficacy was starting to flatten out. What we're really meaning here is that in a lot of ways, the lighting low-hanging fruit that's still out there from an energy code and a savings standpoint really starts to look like adding in advanced or networked or luminaire level lighting controls in such a way that they maximize the benefits of light from a visual standpoint, but also from an energy standpoint. So this is a slide that some of you have probably seen before. I haven't seen anything that is actually better than this yet. And believe me, I looked around in the last couple of weeks. What this is really showing us is kind of where we think we're going from a utility standpoint with respect to aggregate energy savings moving forward, sort of from where we are today into the future. And you'll see that networked lighting controls becomes more and more important. And that's going to be reflected in both utility programs and in energy code cycles today and moving forward.
I would just add to what Shaun just said by saying that the other piece of low-hanging fruit is the existing building stock that's still limping along on outdated technology that's just ripe for being moved over to high quality LEDs with good controls. Another chart you've seen before that we're focused on these four basics for moving the Seattle code forward over these last several years, and today we're not just doing lighting, but we're doing lighting and electricity. And so making sure that clean electricity that we do have, which is when we start adding in all the vehicles and all the existing buildings that are currently gas heated and like that, we've got to make sure that we make extremely efficient use of that electricity we have from the dams and from our other renewable sources, so we can keep city light at its high level greenness, and that anything that we're building right now has to, without any major surgery, be capable of hitting our zero emissions targets in a couple decades. This is a mechanical slide, but I just wanted to mention, since we're on the topic of electrical, that the last code, I mean the code that we're under right now and the future one, saying you gotta do your heating with heat pump, and the big exception there that's most important to most people is that we allow a certain amount of electric resistance heating in apartments if they have a great envelope, which they have to have now. That's usually not a problem to meet those standards. But just be aware that when you're designing electric systems, that you're designing for either electric resistance or heat pump. And for water heating, this also just went statewide, so that Washington State took on most of the Seattle rules from the current code and put them into the 2021 Washington State code. So you've got heat pump water heating coming your way around the state. the one big difference is that the Washington State rule allowed the supplemental heating, that heating that you need for very cold weather or unusually high loads, can be gas or electric, whereas in Seattle it can only be electric. There's a lot of exceptions, but anyway, when we get to lighting controls, getting into the code stuff, that first pathway is just do LLLC. I couldn't figure out at first what luminaire level lighting controls means, but it's as opposed to room level lighting controls, where these are at the luminaires themselves. You can do that for everything, or you could go through the rest of the lighting control section and put in, the occupancy sensors in the various spaces and the time switches and the daylight controls and all that. I think Shaun will talk to us a bit about what the cost balance is these days between those two pathways. Shaun.
I think we'll discuss costing a little bit later, but LLC just rolls off the tongue, doesn't it? LLC. So just as a quick, I always like to give people a bit of a primer, since lighting controls for many, many people continue to be a bit of a mystery, which is unfortunate because they're easier and less expensive than ever to implement today. So it's very important to kind of think this through. From a codes standpoint, there are a handful of the typical lighting control strategies that we really tend to focus on. Things like occupancy and vacancy sensing, daylight harvesting, right? Time scheduling. I don't have task tuning listed there, but task tuning is also a big one. We'll see some examples of where that might be important for us. If what I'm saying here seems like Greek to you, take a look at the link here. This is on the Lighting Design Lab webpage. This is a link to a 4-hour Fundamentals of Networked Lighting Controls class that I delivered last year. And that will bring you up to speed with a lot of this kind of stuff. Duane, the next one. So a big part of this is, why do we wind up using lighting controls, right? Why do we wind up caring about this? From a codes standpoint, it's the bottom two there, right? Energy savings and energy codes. From the perspective of an end user or a building owner, those might not be the only choices, right? We might look at some of what we call non-energy benefits, the flexibility inherent in our spaces, the increase in productivity from happier workers, user satisfaction. Sometimes it's aesthetic, sometimes it's maintenance. There are a lot of reasons to use advanced lighting controls. Those just happen to be side benefits of the fact that we need to use them from an energy code standpoint, which is terrific. One of the things that's been difficult over the years is how to quantify those in a bean counter kind of way. The Design Lights Consortium has been working on a program here of evaluating those non-energy benefits. There's a lot of different ways that you can start to look at that, but if that's of interest to you, Google through that and start to look. From a lighting control standpoint, however, from a codes point of view, Duane, can we go to the next slide? Let's go ahead and take a look at how we might look at a typical kind of space. Last time we did this, I showed you an office example, an office space example. If you're interested in that, go back to one of the previous code classes and you can look at that. In this case, I put together a quick little school space example, right? So if we look at this, we've got a slice of a typical, let's say, double-loaded corridor classroom wing on a school. Let's imagine that everything is perfect and we have the building oriented east-west so that we have a dominant south exposure and a dominant north exposure. That's what we want if there's anybody out there doing schools from a daylighting standpoint. And we've got 3 classrooms, a corridor, a lab, a storage space, a prep space, a couple of offices. So we have a lot of different places. But again, from a codes standpoint, we're typically really concerned about occupancy and vacancy sensing, daylight harvesting, task tuning, time scheduling. Duane, go to the next one, please. So Duane had mentioned the whole idea of luminaire level lighting control. That's adding all of the sensors, all of the gear into each one of the light fixtures. We'll talk about this space and some luminaire level lighting controls a little bit later in the talk here. But from a traditional networked lighting controls approach, which is basically what I would call a parts and pieces kind of space, we can look at it more or less like this. Duane, next slide, please. So when I'm thinking about controls, I typically first think about turning the lights on and off, or depending on the space, turning the lights on when I press a button, or having them turn down to a specific level, depending on how the particular space is configured. So how do I do that? Well, I do that with an occupancy or vacancy sensor. The difference between the two for all but one manufacturer I'm aware of is a toggle switch, either an electronic toggle switch or a physical one, right? So the difference between the two, occupancy sensor turns the lights on when you walk into a space. Vacancy sensor turns the lights on when you press a button, not before, right? You have to actually physically engage it. They both turn the lights off or turn the lights down after a certain predetermined time period. Typically these days, something like 15 minutes, right? Used to be 30 minutes, but that was predicated on fluorescent lighting. So in this particular case, I would need to add occupancy and vacancy sensors into each one of these rooms, probably a couple in each case in the larger ones, to ensure that we had adequate coverage. Next case, Duane.
Yeah, and just to reiterate, when they come in the box, they can be either, right? You can flip that toggle either way.
For all but one manufacturer, yes, they can be either or. Then on top of that, you layer in the daylight sensor, right? So you put in a daylight sensor, at least one into each space that you're in. You'll notice that there's been a change in the current code that requires, what is it, Duane, 60 lineal feet, I think, something like that per facade.
In Seattle code, a maximum of 60 lineal feet of a facade can be controlled by any one daylight sensor.
So pay attention. So pay attention to that if you have like large open plan office areas and you're not doing LLC. So you have to add in all these parts and pieces. Duane, next slide, please. Then you wind up adding in all of your wall stations, right? All of your controllers within each place, and those are going to depend highly on whether or not you're doing manual dimming, whether you're doing preset scenes, whether you're doing a variety of different kind of options within this space. So you start to see that parts and pieces kind of accrete very quickly. This is a lot of stuff that you have to pay attention to from a design standpoint and also from an installation standpoint. Where do these things go? How many of them do I need? What are the overlapping? All these kinds of things. Then, next slide, please, Duane.
And you got to commission them all.
You got to commission them all. And speaking of commissioning, you wind up really paying attention and putting together somehow a sequence of operations, right, for all of these individual parts and pieces, meaning you got all this great gear. What is it supposed to do? How is it supposed to dim? When is it supposed to turn on and off? How long is the offset for the occupancy or the vacancy sensor? What are the daylight dimming levels? All these kinds of various things that need to be paid attention to. We'll talk more about this towards the end when we talk about commissioning. But I just wanted to give you a quick sense of how much really the practitioner should be paying attention to these days with respect to controls, particularly for the network lighting control. We'll talk about how much easier LLC can be in just a little bit. Duane, I think back to you.
So in case you haven't noticed what's going on here, I'm just saying what the code requirement is, and Shaun is then giving you some tips about the details and the possibilities of how to make it all go. There's this sort of miscellaneous section called additional lighting controls in there. And there are several you see at that top bullet that just, the only additional lighting controls that they have to have separate switching from the main general lighting. And that's just so, you know, maintenance comes in to mop or something like that. They don't have to turn on all those display lights and so forth. Those would get controlled separately. Hotel rooms have their own special requirements, and those are those now. The more sophisticated controls are becoming dominant already, so it's not such a problem. Dwelling units have theirs. I just wanted to mention that last bullet point is the exit access. And for those of you who are not building code geeks, there's the exit is the stairwell, you know, the fire rated stairwell, or the door that goes from the inside to the outside to get out of the building. Everything between your desk and that door is the exit access. And there's still lots of tall buildings downtown that you'll see always have this glow, because like 1 out of every 8 fixtures or something is on to provide egress illumination. But the newer buildings, when the general lighting is off, that exit access is also off. They do flip on automatically if there's a power failure because they're on a different circuit, but everything shuts off.
Thank you.
Go ahead.
Thank you for that additional clarification, because lighting practitioners, we tend to be a little bit lazy sometimes with our language. There's commissioning and startup is another sort of example of that. We tend to think of everything that has to be on an emergency circuit or a battery or something as emergency lighting, even though you're right, it's not necessarily always that. But one key thing that sometimes trips people up is this notion of emergency or egress lighting. Right, back in the day, we used to do things like we see in this image from the Spokane Public Library, where we would have a certain percentage of light in large areas that was on what we would call a 24-hour circuit. Basically, the lights never turned off, the lights never dimmed, the lights never did anything. I can tell you, I mean, you can see from this photograph, that looks really good, doesn't it? Aside from looking really good, it poses some potential maintenance issues. It also poses, obviously, energy issues. So today, basically all of this light needs to be controllable along with the rest of the architectural lighting. So if you're using architectural lighting for emergency or egress or exit lighting, it needs to be controllable somehow. Most commonly, that has been done either with things like Bodine backup battery or some kind of generator feed. The good news is that with modern network lighting controls, many of the manufacturers, the actual power packs that they are using, here's an example here from Incellium and another from Incellium and Lutron, and then there's a UL924 device from Wattstopper there. A bunch of manufacturers, their power packs that function within this network lighting control system ecosystem are native UL924 devices. So that heavily simplifies both the design and the implementation of this requirement. So I just wanted to give you guys that heads up. Duane, back to you.
Couple of questions real quick. One real quick one. Eric wanted to know if that exit access was the same as path of egress.
That would everything from your desk all the way until you're out at the street is the part of the path of egress. And it's really divided into 3. There's that exit access to get from your chair or your desk or your dining table, whatever, to the stair or to the exterior door. And then the doors or the stair is the exit. And the third is the exit discharge, which is from that exterior door out to the street. so there are different requirements for each of those segments of the exit access or of the egress pathway. But certainly the exit access comprises like 95% of the floor area of your building.
Okay, and then Jose had a question on sensors and controls in the code. He said, in reference to C405.2.1 and C405.2.2, does the code verbiage allow us to provide time switch in lieu of occupant sensor controls if rooms are required to have occupant sensor controls per C405.2?
No.
Okay, got it.
When it says you got to be aux sensor, they do, and then everything that doesn't have to be aux sensor typically has to be on a time clock control. But we really want those, especially smaller rooms. We want those off when there's no one in there to appreciate that lighting.
And there's a very, very small subset of very well-defined spaces that can have time clock control. Is that correct, Duane?
Well, if it says it needs an occupancy sensor, then
it needs an occupancy sensor. Yes,
that's what it needs. And there are other rooms that have other room types that have other requirements, but no, you gotta have those aux sensors. It's something that I've noticed that people who probably 95% of projects do not have a professional lighting designer involved, and those are the projects that often get aux sensors that are really inappropriate for the space. And there's all different kinds, and sometimes you use them in multiples of them together to make sure you got complete coverage. And if you've got toilet stall partitions or open office partitions or something like that, you have to like accommodate all those things. So that's where having a pro involved really helps.
Well, and just a quick follow on. So Jose follows on. In California, we typically do not provide occupancy sensor in electrical rooms, for example. Is this a safety issue? So Jose, what I would tell you is
sensors is not part of the list of places that require an electrical room is not on that list of required spaces that need aux sensors.
So take it as written that in places where there are going to be safety issues like that, then you're not gonna need it in that particular space.
Yeah, and that's.
But Jose, we're gonna move on. We can address the specifics further at the end if you'd like.
Also, look at the very first part of the lighting control section, C405.2. There are several general type of exceptions that get you out of this for and spaces like that where you have specific safety needs are part of them. So you don't want something accidentally turning off when you're like changing a circuit in there. So one of my favorite pictures, here you've got like 4 acres of parking lot blazing with light, and I see 3 cars out there and no people. And boy, you drive through SeaTac or something, you see an awful lot of that. The idea is that for facade lighting, it's shining up on the facade of your building, or landscape lighting, those little turtle things that are making pretty pathways for you and all that has to shut off midnight to 6 a.m. Other kinds of lighting, which would include this parking lot, have that same requirement, except they don't shut all the way off. They have to shut down by at least 30%, either in that midnight to 6, or if they're not noting any activity. I have to say that I've talked with campus security people a few times, and they love it when they get parking area lighting on some kind of motion sensor, because they can see from a quarter mile away that for some reason somebody's over in parking lot C4, and they go and check out what's happening. And you can, yeah, just any kind of movement makes lights come back up to bright. But you've got those choices, but you do have to get things to turn down or turn off.
As part of that, there has been a real resurgence in the idea of lighting controls or advanced lighting controls for exterior locations, both for parking lot, parking garage, but also for things like pedestrian walkways and that sort of stuff. So whether you're doing it now or not, assume that in the near future, we're going to be talking about things like dimming and task tuning, dimming rather than switching, scheduling, of course. We might also be talking about things like tunable white. At Light Fair last year, I didn't make it this year, I'm afraid, but at last year, there were a couple of talks specifically about the potential for color tuning light sources within the exterior environment in order to accommodate things like the human visual system, visual acuity over time, but also then to look at things like migratory bird patterns or impacts on flora and fauna, which are significant. Also, you'll find, next slide, please, Duane. Sorry, go ahead.
Last bullet point, say amber with a question mark.
Oh, so sorry. That's part of the whole color question. There is a significant movement out there within the lighting industry that is discussing the use of amber, going back to amber light exterior rather than sort of the whiter or bluer light. We'll all remember that high pressure sodium, for example, was a relatively amber light that didn't have a lot of blue in it. There's a certain percentage of folks who think that that's probably better for the nighttime environment since blue-rich light has more energy within it than sort of the longer wavelengths like amber. So personally, I think tunable white's probably a better way to think about this, and it's not terribly difficult to do, but that's a whole side question. However,
a lot of laptops will now switch you over to amber as it gets later in the evening, which is supposed to be better for your sleep, is it?
Yeah, that's a discussion we don't really want to get into right now because that's its whole talk. But from a control standpoint, companies like Georgia Power, for example. Georgia Power is an electric utility in obviously Georgia. One of the oddities about Georgia Power is that if there's a street pole or a parking lot pole in the state of Georgia, the odds are that they control it, right, one way or another. So they've long advocated for centralized control of these things. Now they're actually using DALI. DALI, digitally addressable lighting interface, offers a lot of opportunities for things like color tuning, potentially, but other various types of data transfer as well. So if you're interested in this, they did a great talk at Light Fair a couple years ago, and this article, you can follow the link down at the bottom there. Now, next slide, please, Duane. Everybody's taken this seriously. At this year's 2023 IES annual conference, the theme is Light Responsibly. In one of the days, only one of the days, we have three major talks that all have to do with, at least in a significant part, outdoor lighting. And in these days, when we're talking about outdoor lighting, we're also talking about outdoor lighting controls. So assume that this is stuff that is going to be really important to you. So it's not just going to be the, turn the lights off from midnight to 6 a.m. There's going to be a lot more of it. So gear up and get ready for it. Okay, next. Back to you, Duane.
So the Washington State Code has taken on the latest ASHRAE lighting power allowance ideas. It's interesting because as they get more sophisticated, oftentimes the small rooms, which have always been hard to light to those standards, are allowed a little bit more leeway. understandably, but it's going to be about a 6% drop overall. In Seattle, as with our previous codes, we maintain those lighting power allowances 10% below Washington State. This follows that these the research gets done a few years ago, and those get into national standards, and then we pick them up in the state and then the city. But meanwhile, the lumens per watt that you were just hearing from Shaun about continues to improve 5% or so a year, and is expected to continue that way for a few more years. And so by the time that people are bringing in projects under the new Seattle code, where the industry has already picked up that 10%. We have a few footnotes in there at the bottom of the lighting tables I just wanted to mention. The classroom one, I think we've had that in there for quite a while, but a certain amount per lineal foot of whiteboard. For this kind of miscellaneous grab bag of different room types, there's an extra chunk for what's considered ornamental lighting. That's just something that's not the general lighting. And then in the Seattle code in particular, we have an extra 1/4 watt per square foot for display and decorative lighting. This came to us from people who do hotels and said, our current sort of plain potatoes corridor lighting just did not work for a high-end hotel. And when I went to prove them wrong, it turned out that they were right.
Thanks. One of the key things that we keep being asked as these code cycles come through is how am I going to be able to meet them? So one of the sort of key facets of this kind of class series has been, and will remain, I suppose, giving you some examples, right, with modern equipment. What we have here is an office example using 1x4 troffers, right? The photograph is typical one of my projects, so I modeled on that. Our current allowance for the lighting power density in an office space like this is 0.51 watts per square foot. Taking what I would consider to be middle of the road in terms of, I hesitate to say quality, but let's just take that as written. Basically, middle of the road cost luminaire 1x4 modern plain Jane. What I've done here is done an estimate. So my target light level for this particular project is 25 foot candles within that space. I'm estimating that I'll be seeing 34 foot candles, standard reflectances, 80, 50, 20, 80 for the ceiling, 50 for the walls, 20 for the floor. And the actual power density that I'll see in here is actually about 0.4 watts per square foot. So handily exceeding the requirements without any real problems here. And that's giving me a pretty significant amount of leeway for task tuning down to that 25 foot candle level. So I'll actually probably be using somewhere around 0.32, 0.33 watts per square foot. And of course, from a control standpoint, I'll add in vacancy sensing, daylight harvesting, and manual dimming. We'll talk about the requirement for dimming versus step switching a little bit later as well. Duane, could we go to the next one?
Yeah, I just wanted to note that Shaun's easily surpassed a 20% reduction below the allowable lighting power allowance, and so you can go for that C406 credit, and your client will love you for that.
So, you know, one of the things that I often hear is that it's more difficult to meet energy codes with indirect lighting. Okay, I don't agree with that, but okay. So we've taken a different example, right? So we've got linear indirect, direct luminaires within a space. Again, allowed 0.51. Again, my target light level is 25. My estimated average is 29 in the example. And I'm at a 0.36 watts per square foot. Again, I have some level for task tuning here, but not a great deal. And again, we're looking at basically 80, 50, 20, right, is the reflectances. What if we go to a classroom? Duane, next slide, please. So classrooms are also places that we frequently hear have been challenging. So you have two things going on in classrooms. One, you have budgets. Two, you have the idea that we really want to go to the best possible outcomes for students and educators. So our allowance is 0.65 watts per square foot. As Duane mentioned, we have an additional allowance of 4.5 watts per lineal foot if we're lighting whiteboards. In this particular example, we haven't lighted the whiteboard. Why? Because, well, it's more expensive. So we've just got general area illumination here. So my allowance is 655 watts based on a 1,008 square foot room. The general area lighting here is giving me an average of 52 foot candles instead of the 30 foot candle minimum that's required by the Washington Administrative Code, which is written very poorly to require a minimum 30 foot candles, which trips people up sometimes. It really should require an average 30 foot candles. But in order to get that, that light in the corners, which is where it trips people up, we actually have to bump up to 52 foot candles. Even giving that, we're actually at 0.61 watts per square foot, right, which is under the 0.65. Now note, we also want to have vacancy sensing control. You could have occupancy sensing as well, which would bring the lights to 50% light on when you walk into the space. Personally, I prefer to have the actual control of vacancy sensing in places like classrooms. So what if we go ahead on the next slide and actually adopt a better solution of lighting those whiteboards at the perimeter? Turns out lighting surfaces can actually be better for us, both from an energy standpoint, but also from a visual standpoint. So we're not just trying to blob light everywhere with the troffers. Now we've got still a 51 foot candle average, but with the allowance, our proposed general lighting is 0.43 watts per square foot, but our aggregate is 0.59 watts per square foot because we actually can use the light from the perimeter lighting, which is very useful. So we are under significantly. Our proposed lighting is 597 watts. Our aggregate allowance is 853 watts. Now, pay attention. You need to include the actual light fixtures in there to do that in order to make this work. Again, vacancy sensing, scene control, and daylight harvesting, because we've got dominant windows on one side. Okay, so again, what if we went to an indirect solution? Can we do that same thing? And the answer is yes. So here's an indirect direct solution, same classroom. Now note that the ceiling height in the first examples were 8 feet, which is fairly common ceiling height, right? Unfortunately. Better places to work and go to school have higher ceilings, right? In this case, 10-foot ceiling. So it will allow indirect direct lighting, but it will also allow for a better penetration of daylight within the space, right? The higher the space, the higher the windows, the deeper you're going to bring daylight into the space. So these are all terrific things. In this case, we have an aggregate allowance, again, of 853 watts. Nothing else has changed there. But our proposed lighting is 592 watts. You'll note that we have gone down to 45-foot candles from 51, so there's a slight diminution in the amount of light you couldn't possibly perceive. And we're still meeting our 30-foot candle minimum, which is a little wonky. So what if we went ahead and Duane had mentioned the corridor spaces. So what if we take a look at the corridor here? I've assumed a target of 10 to 15 foot candles for our corridor. There are going to be folks that will tell you that 10 to 15 foot candles in a school corridor may be a little low. Who knows? In this case, this is my target, right? That certainly meets the recommendations of the IES for a corridor space. But you'll note as we go through that there's plenty of headroom here. So we've got a 0.4 watt per square foot allowable, and then the additional 0.25 watts for display and decorative. Since I don't have any display and decorative lighting in here, I'm not taking that allowance. However, I am calculating a 14 foot candle average in here, and I'm coming in at 0.17 watt per square foot. So you'll note that we actually have a pretty fair amount of headway here. Duane, go to the next one. What if I want to add some display? So maybe in this school classroom, I've got some pinup boards, maybe I've got some murals, maybe I've got some other things. If I go ahead and do that, my proposed aggregate bumps to 0.26 watts per square foot, but look where we are with our allowance is 816 watts, and our proposed lighting, including the display, is 424 watts. So we're basically half the allowance that we have here. Now, I want to be clear, this is not, I mean, this is a school classroom. This is not going to be the Hyatt, right? This is not going to be a high-end hotel. This is not going to be a high-end office project. But Duane, the next one, it will work in most sort of typical office spaces, you know, typical office floor elevator corridors. It will work in places like multifamily. This is a great example from a few years ago that you can see the Delta snapshots if you want to learn more from the Lighting Research Center in New York. They did a project where they took an existing multifamily development. They replaced the existing fluorescent lighting with LED-based fixtures with luminaire level lighting controls. They oriented them better for human vision than the system was before, but they did a one-for-one luminaire replacement, right? They just put a different light fixture in and spun it 90 degrees, so it worked better. Didn't have to rewire anything, didn't have to do any of that stuff. They actually increased the light level. In this case, the lighting power density was 0.38 watts per square foot. So this was several years ago, and this would still meet our power density today. Next one. And what they found was that they had fairly outstanding energy results with respect to using the actual luminaire level lighting controls. All of the controls, the occupant sensors, daylight sensors, all that stuff in each light fixture. So all they had to do was take the existing fixtures down, slap up the new light fixtures, and then commission them with a tool that looks an awful lot like your smartphone, right? And they're seeing savings like this. One of the key results here was that very frequently we find that people are afraid of having automatic controls in public spaces like corridors because they think that their clients are going to object to them. What they found was that dimming to 20% light output when people weren't in the corridors was not objectionable to most of the people that were there. In fact, they liked it. So this is one of the things that is really generating the idea that in corridors, in egress stairs, places like that, we dim the lights down. We don't turn them off, we dim them down so that it never goes dark, so people never get the perception of a safety problem, but that the lights will ramp up and you're still harvesting 80% of the energy there. So Duane, I think we're back to you unless you have anything to add to that.
So Shaun, when you look out peephole in your apartment door with 20% light out there, you're still fully able to see who's in the corridor?
Yeah, you may not see quite the same detail that you would see once the lights ramp up again, but you absolutely are not walking into darkness. And the sensors react very quickly. Again, we're talking about a sensor per light fixture. So there are a lot of sensors in the corridor there. And as soon as they see you, they're going to ramp the lights right up.
Okay. So was I going to talk about the germicidal lighting, or you?
I think that one's on you.
Okay. Well, it's still a little controversial about how this works and where you would place these fixtures, but I believe we've made an exception that says it's not going to count against your lighting power allowance. I have seen them used in supplied ductwork as a so that all the air coming in is running past these lights. But especially given that the extra attention has been paid to this topic since since COVID, this might be something that helps put your client more in a comfort zone. Whether anybody over the years goes up and remembers to change and service those fixtures, I don't know, but it could help.
The only thing that I would add to that, if we can go back for 1 second, so ultraviolet radiation, as opposed to light, right? Light implies the idea that we can actually see it. We don't see the active portion of this ultraviolet spectrum. So, so it's not really lighting to begin with, but it does fall under electrical, which is also what we're talking about here. So that's a distinction that's important, because a lot of times I've been asked about, why is this involved in lighting at all? Because we're talking about an electrical part of the thing here, and it's not at all uncommon to find UV radiation used, as Duane mentions, in ductwork. It's not at all. In fact, it's very common to see UV used in water, right? In water purification. So there are a lot of different uses here. There are, from COVID, of course, ramped up the interest in this, but we've been using ultraviolet, particularly aimed at the ceiling and aimed in higher spaces, for things like tuberculosis wards for many, many, many years. So this is not actually new. There is a good amount of discussion out there with respect to whether germicidal is valuable for fighting COVID, whether and what kinds, right? Whether it's upper air or whether it's actually on surfaces. If you want to have more information on that, Google to the IES, the Illuminating Engineering Society. They did a great symposium on this last year or the year before. And I believe the proceedings are available, so you can find out probably more than you ever really wanted to know about GUV.
Yeah, it's tough because it's hard to do large scale double blind experiments. Put UV treatment in one air supply to a building and have another building just like it that doesn't have the UV. So there's a lot we still don't know. As Shaun was just referring to, that in my little diagram at the bottom there, that lump in the middle is what we call light, and what we see, and it's what lumens are, is some aggregate of that area under that middle curve. But the bimodal curve you see running behind it is what plants see, and they really like this infrared and ultraviolet light. And so for judging the efficacy of our beloved indoor horticultural fixtures, around here most everything is warehouse type, and so you need to have 1.9 micromoles per joule. That doesn't mandate LED. There are still some growers who insist that there are special effect, whatever that is, depends on a different light source, and I think double-ended HIDs, the best ones of those can still meet this standard, but we're not talking about lumens for these spaces because lumens are for humans.
Those are tulips, right, Duane?
I'm pretty sure that that's a special kind of tulip. Yeah. Another code thing for open office is and I think I said Seattle here, but I think now it's in the new Washington State code as well. It over 5,000 square feet of open office area, you've got to choose either the LLLC fixtures or a network lighting control system. I'm thinking of my office floor plate is big enough that you could have 5 of those 5,000 square foot open office areas. So it doesn't take a really super large space to need to roll into this.
So luminaire level lighting control, again, that just kind of rolls off the tongue, doesn't it? Unfortunately, we don't.
Well, unless you've had a couple of drinks already, it might be a little harder.
well, it takes a little bit, but the idea is, and hoping that this is not new to anybody here, and if it is, again, go back and take a look at my Fundamentals of Lighting Controls class. There's a lot of information there about it. Also, NEA, Northwest Energy Efficiency Alliance, has a good amount of info here. The idea is that instead of having a more typical approach where we have sensors in the ceiling and for occupancy, vacancy, for daylight, things that talk to the light fixtures, we actually take the sensor itself and put it into the light fixture. So every single light fixture has an occupancy and vacancy sensor on board, so that we have a robust network of sensing capabilities within that space. Now, I will tell you that that does in fact increase the cost a little bit, the upfront cost. So there is, I mean, depending on really whose numbers we're looking at, depending on what fixture, what system, you're going to typically wind up seeing somewhere between probably, I don't know, say 25 cents a square foot, maybe $1 a square foot additional cost for luminaire level lighting controls in the upfront sense. However, literally everybody that I've asked about this in the last couple of weeks has agreed that the actual installed cost, including the startup and commissioning and all that stuff, is actually at best a wash, and actually may be cheaper with LLLC because it's so much easier, right? So let's go to the next slide, Duane.
Yeah, by the way, Shaun, I just did a time check here and we are running a little behind schedule.
Okay.
And we have a few questions too.
Okay, let's grab them.
So the questions that we've seen, Katie, if we could leave those to the end, those are sort of general questions.
There is one on the slide about Open Office LLC that came in while you were talking. Do you want to address that one?
Yes, and Dixon, I will address that in the next few slides.
Oh,
Thanks, Shaun.
So we're going to defer that.
All right.
Okay, so go to the next one. So some of the key things with respect to luminaire level lighting controls, you can go to the resources page here and you can see some of the sort of specific information here. But the key thing here is that it maximizes flexibility. How? From a design standpoint, I don't have to worry about doing very detailed zoning diagrams, for example, for my particular projects, because every single light fixture is its own control zone. Simple. I don't have to worry about, from an installation standpoint, worrying about bringing things like pipe and wire to the fixtures for control. Why? Because the control's already in the fixture and they communicate wirelessly in almost all cases. So being able to simply put a light fixture up into the ceiling, bring power to it, a hot, neutral, and a ground to it, and then ultimately set it up and commission it using a smart device that looks just like my phone or a an iPad or something similar really makes it quick and easy to set up, but also makes it really quick and easy to change over time, right? So we can go ahead and do things like, let's say we have a large space that's got demountable partitions, for example. Leave the fixtures up in the ceiling, move the partitions around, and just reprogram them. So other big part of this here, as Duane mentioned, if you've got LLC light fixtures, they automatically meet energy code. There's a lot less documentation that has to be done from a design standpoint. Also, if you are doing retrofit projects, I'll show you an example of a retrofit project briefly. You wind up, most utilities nationally now will actually pay you somewhere between $50 and $75 per fixture for LLC, because they recognize that this is an important step forward in the next generation of savings. Duane, next slide. So NEA, Northwest Energy Efficiency Alliance, did a study a couple of years ago with Kevin Vanden Wijmelenberg down in University of Oregon, and what they decided was that replacement light fixtures saved up to 74% energy, with LLC. That's great. But what they wound up deciding was that redesign saved a certain amount of energy, but replacing one for one wound up being the simplest and the most advantageous option for retrofit applications. Why? Limited rewiring, limited ceiling work, lots and lots of different reasons. So that's actually a pretty good deal. Now, next slide, please, Duane. From a back to our school example, right? We saw the traditional networked lighting control approach, where we're having lots and lots of parts and pieces here that we need to pay attention to, that we need to install separately from the light fixtures, that we need to design. Duane, next slide. With the luminaire level lighting control approach, every single one of the light fixtures is going to have all of the gear in it that is required in order to function, right? It's going to have the occupancy and the vacancy sensors right on board. And then next slide, Duane. The only thing we really need to pay attention to, and other than that from a design standpoint, is where the lighting control stations are going to go and what kind of configuration they have. Is it a manual dimming switch? Is it a preset selection? Is it something else? Next slide, Duane. And you'll see that from a sequence of operations standpoint, it's more or less the same, because you're doing basically the same functions. You just have slightly different configuration of the hardware. Now, your control zones may change, right? Because every light fixture is a control zone, so you may document that separately. But yeah, that's not a big deal. Next one, please, Duane. And from a resource standpoint, the Lighting Design Lab has a tremendous amount of information that is available on the whole idea of network lighting controls and LLCs, including, as I mentioned, the classes that are recorded that I've delivered in the past. But there's also setup videos. There are a variety of these learning guides, a lot of information there. So avail yourself of that. Now, because this is so important, right? A few years ago, we started a project with City of Seattle, right? So the Seattle Municipal Tower the lighting design was done for it back in the 90s, and they used a specific 2x4 and 2x2 series of luminaires that were actually really high performance for the time, great stuff, but they're worn out, right? It's time to replace them. The problem is, or the big problem is, as these things fail, the manufacturer no longer makes the light fixtures, right? So one way or another, a new standard is required. So in 2019, we had a great partnership with the Lighting Design Lab, Facilities, FAS Group, and City Light. And we sat down, we hosted a mock-up at the LDL to review some of the alternatives. And we selected a series, group of typical types of recessed LED light fixtures, all of which were going to be equipped with LLC at that time. Next one, Duane. This is what I like to consider the city of Seattle sort of walking the walk, right? They are looking at requiring things like LLC. So in this project, we've gone ahead with a high performance recessed dropper. It's LED based, and it has an LLC control system, right? So following NIA's guidance, we've gone ahead with a 1-for-1 swap out in the light fixtures. This is a drawing courtesy of DLR Group, who's been doing the design for it. Great group of folks. The existing 2x4 luminaires were 2 T8 56-watt fixtures. The retrofit luminaire is an LED base using 32 watts. So the luminaire savings alone is about 43% over what was there. And the overall estimate is about 0.4 watts per square foot, somewhere in that range, versus 0.51. So this is the city actually going ahead and doing what they said they should do, right? Next slide, Duane. Actually, let's go back to one. One of the key things here, one of the key reasons that we wanted to go to LLC was very specifically the fact that it was going to be tremendously easier from an installation standpoint to go ahead and replace the existing fixtures 1-for-1, right? The existing controls were minimal at best. They're basically a handful of relays within the floor. So we've gone ahead and have a situation where we've got the existing wiring, hot, neutral, ground. Great, put it up there. So that all is fine. And then the additional controls that we get, occupancy and vacancy sensing, is all based on the fixture itself. Duane, can we go to the next one? Sorry. Okay. So as most people here will know, your energy savings from controls has to do with things like task tuning. What's your task tune level? We can task tune with these fixtures. What is the occupancy of the space? Well, at the moment, and through all of COVID, lights were on from 7 a.m. to 7 p.m. I think those are the operating hours that the system is set to at the moment. But that's it, right? Except in places like conference rooms, there were no real lighting controls. There's some minor adjustability for perimeter daylighting control, but now we actually have, or will have, the ability to go ahead and have very significant fine level control over specific areas. City Light is estimating that the control savings will be about 60%. We don't have the full numbers yet because it hasn't been occupied yet. But the estimated savings per floor is about 29,000 kilowatt hours per year. So multiply that by 57 floors. That's a significant change. All right. Next slide, Duane, I think is you. I hope that, unless you have questions.
And don't forget that that's also energy that does not have to then be swept up by the chiller system, and we don't have to expend energy to get rid of that extra power during all those hours of the year when an office building is in cooling mode.
Dixon, I hope that answered your question. If not, go ahead and ask it again, and we'll answer it towards the end.
We've always had a section called light reduction controls, where which is still in the Washington State Code. You know, things that don't have aux sensors or daylight sensors end up, which I think is like the inboard areas of offices and gyms and some other things, have to have a control that you can turn it down to half the lighting. This is all going away based on what's happening with the national standards for Seattle anyway, and we're just saying no. For all those spaces in the table on the left, you got to have dimming. It's not expensive. It's people can, at the worst, you know, they will have it at full tilt, but I've discovered that when you give people options, often the consensus is we'd like it a little dimmer, makes it more comfortable for using your computer. Do note that at the bottom of that list, there's a catch-all that says any place without an occupancy sensor, right? Which I presume includes vacancy sensor controls. On the right side table are these exceptions to that, and you know, they say, well, okay, any place that's got daylight controls, or as long as you do have some kind of light switch, a room that only has one luminaire, or that has very low lighting levels. Now, actually, that encompasses most of the spaces that Shaun was just saying, so you might get out of it there. But also accepted is corridors and electric rooms, mechanical rooms, lobbies. Those do not require the dimming controls.
All of that said, the reality is that dimming is endemic, right? We're no longer 25 years ago when dimming required additional gear. Basically, every light fixture commercially available that you're going to use in a project today has the ability to dim. I'm sure somebody will point out that there was some project that they had 2 years ago where there was one fixture type that couldn't dim. Okay, fine. But most projects, most of the gear is going to be dimming. And the fact is that smooth dimming is tremendously better than step switching or checkerboard switching. Why? It's less obtrusive, it's more even, and it's frankly easier and cheaper now than doing the step switching, right? I actually did a project for a shoe company down south of the border a couple years ago, and the managers swore up and down that we were not going to do dimming controls in their parking garage. There was going to be step switching. Great, you can pay extra for step switching for those fixtures if you want, but that's non-standard at this point. So go ahead and assume that you're going to be having light fixtures that dim. It usually doesn't cost much or anything to include them, particularly if you to include dimming, particularly if you have network lighting controls or luminaire level lighting controls. It's simply the decision to use one switch type versus a different wall switch type, which usually cost about the same. It's just a choice of which one you want, right? And bear in mind that those non-energy benefits, frankly, from my perspective, are more important than the energy benefits from a real standpoint on a project. So pay attention to the flexibility, the productivity, and the user satisfaction. Dim things. So off the soapbox. Duane, back to you.
So away from lighting for a moment here, this is something that's in the current code and continued on, and I believe is in the state code, that dwelling units, and remember this is the commercial code we're talking about, so we're talking about multifamily. There are certain high-end places that do, I guess, put in gas kitchen equipment in an apartment, but if you do that, it hasn't been prohibited yet, but you got to have a fully functioning receptacle and circuit right there so that at any time in the future that can be swapped out for something electric. For commercial kitchens, we have said, now this is a Seattle rule only, but we're saying that for new construction, wherever there's going to be a commercial kitchen, there's got to be an electrical panel right there inside or next to the kitchen that's got power to it that can handle all of the power required for those gas-fired appliances you have now to be replaced. It's because obviously doing the switch out later in the life of the building can mean having to upsize the electric service, which would be prohibitively expensive. So doesn't apply to existing buildings that were built under previous codes, but going forward, you're gonna have to, even when, you know, most people don't know who the tenant's gonna be on a ground floor retail space. It's all just open. Since retail doesn't really happen much anymore, it's always restaurants of some kind, and some use a huge amount of gas power, and that's just gonna have to be accommodated in your electrical calculations. Controlled receptacles, another thing that everybody loves. You got to have half the outlets in that list of rooms on the left there be controlled to either turn on and off with an occupancy sensor or with an automatic time clock system. You can have split receptacles, you know, with the top half switched and the bottom not, which I've found is the most popular because users don't have to know, you know, they get pretty quickly tuned into the fact that the stuff that's on the top turns off at night and the stuff that's on the bottom, which is your classroom, aquarium, and you know, your little server and so forth, those get plugged into the stuff that's on 24/7.
The one that everybody always complains about is, oh my goodness, I plugged my my computer into the wrong receptacle. Well, this has been around long enough at this point that people should start sort of understanding this kind of stuff. And Duane, next slide, please. The good news is that there are a couple of relatively easy ways to do this, both from a new construction and a retrofit construction standpoint with respect to these relays. Now, you can go ahead with respect to these receptacles. You can go ahead and put in controlled relays that will then feed the circuit that has the receptacles. Typically, that's, you know, a 20 amp relay like the one that we see here from Cooper. However, that can be a little bit of a pain in the butt from a retrofit standpoint. So the good news is a number of manufacturers also make smart receptacles so that they actually are basically nodes on the network lighting control system, right? So like, for example, the one on the bottom right there, it actually has a radio receiver transmitter built in it, right? So and also has a switch, right? You can press the relay switch there if you want to, but it will also respond to the network lighting controls, and you basically just replace the existing receptacle that's in the wall with one of these things. You'll note that one half of it is controlled, one half of it is not controlled. So really all you have to worry about is just putting the thing in the wall, and it works out just fine. Now, another thing that I will point out is that these things have to be labeled as controlled. So yes, if you're in the classroom and you plug your aquarium into the controlled portion of the outlet, that could be a problem. Which isn't to say that it's always going to be labeled, but it's supposed to be labeled. So, all right, that's it.
And just the whole reasoning here is that any little tiny load that is running 8,760 hours per year has a cumulative energy use that is often more than whatever the item is that's plugged in there that gets used for several minutes a day. So those little tiny loads from computers that are on sleep or whatever really do add up, and it's much better to have them off and cold when nobody is around.
The big one there is laser printers. Laser printers, if they're kept on, they'll keep the platen warm when there's no reason for it. PAE engineers did an internal study on all this stuff a number of years ago when they were designing the Bullet Center, and they found that the vampire loads could be extremely significant. Yeah,
the laser printer is basically an electric resistance space heater for your space that never turns off. We have the C406 extra credit system in there. Don't be alarmed by the numbers you see there. they chopped the old credits up into smaller chunks so that it provided some more flexibility for determining point values for things which this time around are much more scientifically based. But I've just shown with the group E there, the top red oval there mentions that, okay, for the state, you need 48 of these new credits. And for Seattle, since we're obviously cooler than everybody else, that increases by 10%. The smaller oval below is a separate set of credits you got to get for building load management items. For lighting in particular, I've circled a couple of those in that same column. Remember, you need 53 altogether. So that 20% reduced lighting power that every single one of Shaun's designs that you saw easily passes gets you 32 of those 50-something credits. Enhanced lighting controls, which I think some of the other things that Shaun just showed you, gets another 6. But do move forward with confidence if you've got a good lighting design that doesn't need to soak up all that much power. Also, renewables can give you another 13 on there. So you look at that has us about 90% of the way towards that 53-point total we need. With load management, there's a lighting load management. I think that gets everything set up so that if at some point in the future the utility really needs it, you can reduce your lighting power output by an external command, and that'll get you 15 credits. The one that's circled in blue, though, that's a nifty one. You get 72 credits. Remember, you only need the 15, but as battery storage continues to plummet in cost and more clients are interested in that, that could get you also your load management credits. Once again, these kind of things make you really happy with popular with your clients if you find a way that handles those credits easily.
Shaun?
As
Duane had mentioned, it's not really all that difficult to exceed the requirements of the energy code. It honestly isn't. So the examples that we've looked at so far, classroom with troffer, classroom indirect direct, school corridor, typical office, we're typically seeing that we're, with the exception of the strictly general area lighting for the classroom, which is an oddity in itself, we're looking at being somewhere between 25 and 30% below code in each one of these cases. Now, you're not going to be able to do this on every project, right? There are going to definitely be outlier projects where you're not going to be able to do this, but it is doable if that is the goal. And honestly, that was part of the goal in putting together these examples. Now, next slide, Duane.
And remember, that's 20 or 30% below the Seattle levels, right? Which themselves are 10% below the state levels. So outside of Seattle, it should just be no problem at all.
Okay. So those are all hypothetical examples, right? To be fair, they're hypotheticals based on real-world examples, but nonetheless, they're hypotheticals. I do like to put in classes like this a real-world example, and this is one from going way back to the dim recesses of 2017, right? So it's 2023 now. It's 6 years later. What is that? 2 code cycles, Duane?
Mm-hmm.
So this is Miller Hull Studios. It was actually one of my favorite firms to work with, and great fun doing the retrofit for their offices. Right, they're an architecture firm in the Polson Building, which is an old structure in Pioneer Square. They occupy a floor plate It was a TI renovation. They've occupied that floor plate for a very long time. We completed it in 2017. We go to the next one. So basically, Miller Hull opened the space up, got rid of a lot of internal partitions, right? We replaced all of the lighting. We replaced all of the lighting controls. We went from, I think it was 1.2 roughly watts per square foot down to a power density of about 0.3 watts per square foot across this entire floor. Now note, this building does have some pretty good daylighting, so that's certainly part of it. But adding in networked lighting controls, we wound up having the ability to turn lights on and off in specific locations. What they'd had before was the ability for one person to be working on a Sunday and have the entire floor plate, all the lights on. That was their lighting control. So ultimately, at the time we did this, we were actually about 60% better than the Seattle Energy Code. Today, with the updates, this would still be about 45% better than the Washington State Energy Code. Now, sorry, the Seattle Energy Code. So think about that. This project is 6 years old. Even with 6-year-old technology, when LED technology goes in dog years, right? Controls at that point were somewhere between 50 cents and $1 per square foot. Relatively inexpensive for project use today. So think about that. We're not just looking at hypothetical examples. This is a real world example that I think turned out pretty good. So
yeah, that's beautiful space. Here's a slide that's a little out of order, but just wanted to make the point that a small solar array, a really small one, costs a lot compared with a larger solar array. So we're bumping up the requirement significantly in Seattle for rooftop solar, and yet that is bringing down the cost per watt installed. And so if you also decide to take some of your C406 credits to extend that even further, then you will further bring down the cost per watt, especially if your general contractor is coordinated well with the roofers and everybody. We do require that 40% of a roof be the net roof area be set up so that it's solar ready. I don't know why you wouldn't do all of the net roof area, but and that net area is basically the gross roof minus the skylights and the decks and the plantings and the equipment up there. And just remember, you got to have it set up so that you can have big continuous sections. You can break them periodically, you know, if you need some vents to come through. Every 2,500 square feet, you'd have a 2-inch conduit poking through the roof and properly flashed and everything, so they can easily link down through. And the space at the main panel, which I think we'll get to in a minute, note that the issue is often not dead weight, but uplift, and so especially when you get to bigger buildings or buildings that are exposed to the open water or something, you need to have a sobering talk with your structural engineer. That ballasted roofs might be 6 or 10 pounds a square foot, but if you don't mind a lot of pokes through your roof membrane, it could get down to as low as 3. So there's ways to make this work even on historic buildings. Just, I won't get into all the gear you see on the wall there, but just be aware that you need to design, if you're doing the solar readiness thing, that you need to design for that future equipment to have a place next to your main panel on the wall. So like I said, the current requirement in Seattle is 1/4 of a watt per square foot of conditioned floor area. The state upped that to 0.5, and matching something in a national standard that's just gone in, Seattle went with 0.75 watts per square foot. If you want to know how much that is, on the right you can see that okay, if a 4-story building, it would be less than a quarter of your roof area to get all that. 18 stories would just about max out your entire roof. And as you know, the fire marshal is not going to let you do that. There's going to have to be walking spaces around and certain travel paths. And so maybe somewhere on the 15-story level, you would max out. There are other options. You could do some additional efficiency credits in lieu of some of this solar. Note that if you're doing affordable housing, you're not required to put solar on the roof. You do have to do the solar readiness, but not solar. And if you have more requirement than you want to put on your roof or are physically able to put on your roof and you've got no site, you can gift it over to an affordable housing project, either directly to that project or through a state agency fund that is detailed in the code. I think that as the cost continues to plummet, there's a couple national agencies that have said going to pass the $ per watt level for commercial size installations on new construction somewhere in 2028. So more people might want to be directly arranging this with an affordable housing project in town instead of paying $2.50 a watt to that state agency. So just try to organize all the junk on your roof to stay out of the way of your layout. Note that those high angled installations are a thing of the past because they have so much wind load problem, and so typically they're going to be laid down there with just a small walking space between them and probably just a 5 or 10 degree slope. And just get whoever your solar people are going to be on board early so they can tell you if you're about to make some critical error that's going to mess up that installation or make it more expensive. A bit about commissioning. These are the situations where you're going to have to commission your lighting and controlled receptacles. Basically, if it's over 20 kilowatts total, which is what now, Shaun? Is that about a 20,000? No, it'd be like a 40,000 square foot building now, something like that.
Off the top of my head, I don't know. Sorry.
Yeah, and half of that with sensors or daylight sensors. You'll need to commission those things you see on the bullets on the left there, and you're going to need to run it through that functional testing. There are procedures in place to sample so that you don't have to actually check every single one of the sensors.
As part of this, hopefully it doesn't come as a surprise to people that commissioning is finally starting to be required more and more from a lighting standpoint. It's been required in California for a time now. It's been required here in Washington too for a time, but it hasn't really been as uniformly enforced as perhaps it might be. However, it's important to note that within the lighting industry, as I mentioned earlier, we tend to be a little bit lax with language sometimes. So very frequently we talk about commissioning lighting control systems when what we really mean is starting up and programming lighting control systems. Commissioning actually is specific third-party kind of verification regimen. If you need more detailed information on that, the IES has a really nice design guide, DG 2911, that actually documents the commissioning process as it relates to lighting controls pretty well. So take a look there as a good starting point. Next one, Duane.
Yeah, and I might just mention that our inspections group does now have commissioning czar in there who's making this happen more thoroughly than it's been enforced in the past. So be aware and be prepared.
Great. The very fundamental thing from a project perspective with respect to commissioning, and in fact sequencing startup and all that stuff, is having a sequence of operations. Too often folks will design a lighting control system or implement a lighting control system without having a really good understanding of what that system is supposed to do. What it is meant to do is called the sequence of operations. How is it going to happen? What is supposed to happen? So there are a lot of things that really have to be detailed here. What are the time schedules? Which rooms have occupancy sensors versus vacancy sensors? What is the timeout? What are the task levels for task tuning, right? The target light levels. If you're going to have switches or dimmers on the walls, what lighting control zones or which light fixtures, if they're LLC, are they controlling? So these are things that you're actually going to have to pay attention to if you're designing the space. Next slide, Duane. Now, there are a lot of ways that you can convey this information from a design or beginning implementation standpoint. I showed you a matrix, which is one of the ways that I like to do it. We'll see that coming further. Another common way to do this is with a narrative. So this is an example of the kind of information that you would really need to have in order to commission a, in this case, typical private office. This is from a project in San Francisco, the San Francisco Public Utilities Headquarters office. Every typical private office in that particular project was set up this way. And this narrative tells you everything that you need to know about every typical private office in order to set it up. Next slide, please. Another way to do that, I mentioned, is with this kind of matrix, right? So this is a matrix that includes, you'll note on the top, all of the typical kinds of lighting control strategies we might employ. And then you fill it out underneath with the variety of different types of information that you might use. Again, there's more detailed information on how this kind of thing gets set up in that lighting controls class that I've referenced a couple of times. Duane, the next slide, please. This is, again, sort of supplemental information that would be associated with that kind of matrix sequence of operations. Duane, next slide. And the IES is actually working to try to come up with standardized methods of documenting this kind of information so that from project to project, it doesn't continue to be sort of an ad hoc approach of narratives or matrices or however that comes about. So this is a relatively new document that they've been working on. I confess I am not conversant enough with it to be able to tell you much about it other than to say that it's there. And I'm expecting to learn more about this at the IES National Conference next month. Duane, next slide. Completely unrelated to energy codes other than not wanting to have lighting controls disabled. One of the most important things about commissioning is commissioning the occupants. Let the occupants know what lighting controls are supposed to do so that they don't call maintenance and say that the light fixtures that are next to the window are not on, they're not working. Yeah, they're working just fine. They're either dimmed down to a low light level or they're dimmed to off, one or the other, but let them know how it's supposed to function. And then usually you'll get actually pretty good buy-in from most people if you tell them how things are supposed to function and why.
And same with the controlled outlets. You know, as soon as people get the idea that one of them is not just broken, then a lot of good things can happen. So I don't care about meters for when we're going to talk about metering here. I want a display that the building manager can bring up on a screen with their morning coffee and see if anything out of whack is happening. These metering displays are required for the incoming overall energy for the building and for those 5 subcategories you see listed on the right there, as well as full floor tenants. They get their own dashboard that's available to them. Once again, it's probably not a physical piece of equipment. It's probably a website that they get, but anybody that's a full floor or multi-floor tenant would get their own stuff. The idea being that there's not much that the building management can do about what a tenant is doing inside their own space, but I know that my last firm would have had a whole committee going around, tracking all of our energy use in-house.
I've actually had projects where we've done energy dashboarding like this, and they've had competitions floor to floor to see who could use the least energy.
Right. That last bullet point's important. Billing tenants is maybe acceptable under certain circumstances in a commercial building, but do have a little sit down with the people at City Light to make sure that you're not going to get yourself into some kind of trouble. The basic rules for existing buildings are that things that were built even a long time ago, if they were built to code then, you can pretty much leave them alone with very few exceptions. New work has to meet current code always, and everybody loves substantial alterations. That is essentially saying, yeah, you're doing so much work that we're going to call it a new building. Same with a change of occupancy from something funky like a factory or a warehouse to something more polite, or change of space conditioning, from an unheated building to heated or heated only to heated and cooled. These are all 3 of those, along with subalts, are going to be treated not entirely as a new building, but close to it. And finally, anything that Landmark says, don't touch that. We don't touch those windows, don't touch that entry. We will work with you to make sure that you can get your project done and not harm the historic fabric of the building. For retrofits, just want to see, well, actually, is this your slide, Shaun?
Yeah, and the previous one was an interesting image too, because it's Smith Tower, right?
Right.
We actually did a retrofit of Smith Tower back in '99 or so, which at that time basically redid the lighting for the entire interior, and brought it up to energy code at that time. Similar kind of thing for King Street Station. So when we redid King Street Station, it more than met the current energy code, and honestly wasn't that difficult in either case to meet the code. So retrofits in general, just a big thing here. When you're doing a retrofit project, look for suitability, look for redesign opportunities if you can. However, I would reference back to the NIA study that suggested that unless you have a situation where the location of the light fixtures is radically problematic, you can probably do a one-for-one solution and then massage the amount of light coming out of the luminaire to get you to where you want to be. So if the distribution is going to be okay, go ahead. Keep the existing wiring if you can, because that makes things really, really easy, particularly if you use luminaire level lighting controls. Next one, Duane. Just like the SMT relight, the Seattle Municipal Tower relight, the whole point to using LLC light fixtures was to just take the existing light fixture that you see there out of the ceiling, pop a new one up, make 3 connections, and easy peasy, a little bit of programming with an iPad, and we're more than exceeding the current Seattle Energy Code without a huge amount of rewiring or bringing in additional sensors or all that other stuff, because it's all part of the fixture. So the labor savings can be enormous. Next one. Oh,
Hey.
This one's back to you.
So just some general rules about alterations for lighting systems. Our idea was that as the spaces get rehabbed. You know, for offices, it might be every 10 years, maybe for a school, it's every 30 years or something like that. But they keep rolling through this. And so we try to like use that opportunity to bring things up closer to code and keep it proportionate to how much work you're doing. So that first stage is just in any space, if you replace 20% or more of the light fixtures in space or around the exterior, you got to meet those lighting power allowances, which is with current technology just never a problem. Stage two is if you're adding fixtures or you're recircuiting things. Once in a while, there's something comes up and things have to be rewired. Then you put in all those local controls, the switches. Oops, I left light reduction controls in there. That should say dimming. The daylight controls, those aux sensors, those would all go in. And then if it's the third stage, if you're actually putting in a new lighting panel or moving it somewhere with new raceway, then you'd also add that whole automatic time switch system for everything that doesn't have aux sensors in it. Same thing with controlled receptacles. 50% of the new outlets, so you can leave existing outlets that aren't being touched alone, but half of the new ones would be controlled with that time clock or aux sensor, except then we said, okay, not small alterations, not just moving your office cube system around, not the existing outlets. Or things that aren't really compatible with being controlled outlets. Back to metering for a minute. For alterations, if it's a full HVAC system replacement, which happens every few decades in a building, or we're saying more than half of the capacity of that system, then you'll meter the incoming gas and electric and the HVAC system itself. And have that data acquisition and display system in there. If you're just doing a specific piece of equipment and not the whole system, then that needs a local meter for that piece of equipment. If it's a large piece of equipment, the idea being that over a decade or two, you'll replace everything and then you can start hooking that up to a central system. And then if there's a new gas piece of equipment going in, then that would have to also get metered. That last one on the bottom is just if you're gonna rip out the whole electrical system, which happens in those big gut and remodel projects, then that would need the whole metering system to go in. I should say that it's just come up as a proposal in Seattle that rule for metering individual pieces of HVAC heating equipment is probably also going to apply to larger pieces of service water heating equipment. And now I think that Shaun is going to like dust off his old Seattle City Light hat and tell you about incentive programs. Is that how it's going to work?
So just as the last little bit of actually program that we have here before we start to address questions and invite additional questions, as Duane mentions, I'm going to put on my used to be City Light employee hat and just mention to you as part of this, because very frequently we forget that, particularly working on projects in the city of Seattle, that Seattle City Light can be a good partner for design and implementation of some of these things. So City Light has some of the best programs in the United States, and actually long has a very good history of this with respect to things like discounts, rebates, incentives. So we have the ability, or they have the ability, to help on projects as you're moving forward, particularly, of course, on retrofit projects. So Duane, next slide. And I'm just going to give you the quick down and dirty overview that lighting projects They can help with replacement light fixtures and controls. And pardon me 1 second, I'm about to cough. Timing is everything. They can help with HVAC upgrades and with whole building incentives. Next slide. So from a lighting standpoint, of course, they can provide incentives for retrofits of up to 15 cents per kilowatt hour for energy savings on projects. And the big one that should be getting more and more use is the notion of networked lighting controls. So they will actually provide you with $75 per light fixture that is network lighting controls, and additional 15 cents per kilowatt hour for the savings that are associated with that. So from my perspective, I don't understand why any project wouldn't do this, since that basically covers the cost of lighting controls, right, for you. So go ahead and pop into that. Next slide, please.
Shaun, just for those of us who don't ever buy light fixtures in a commercial level, what is a typical that fixture that you have like shown there? What's the overall typical cost to the subcontractor for that fixture? For
like a 2x2?
Sure.
It'll surprise no one to say that that's going to vary wildly based on manufacturer, quality, and so forth, lots of different variables. You can pay for a let's say 2x2 troffer, probably anywhere from say $80 a fixture up to $500 a fixture, depending on how you've configured it, depending on what's involved there. I would typically expect middle of the road, reasonable quality 2x2 luminaire to be somewhere in the $120 to $150 range, somewhere in that, and that's kind of, again, on the lower end. You can go much higher than that.
City Light's paying half of the cost of a typical fixture.
No, remember, there is an upcharge for the luminaire level lighting control, right?
Oh.
So because you're putting a sensor in each light fixture, there's a cost associated with that.
Okay.
So depending on NIA talks about various levels, for example, of lighting control systems, right? From relatively simple to clever to very complicated. Essentially, like anything else, the more you pay, the more control you're going to have, the more refinements you're going to have. The Miller Hull example that I gave you, in 2017, the cost for the material was something like 50 cents a square foot. Today, we've had some moderate price increases, right? So that's probably closer to 75 to $1 a square foot for that particular project if we were doing that today. But the idea would be that if you choose equipment wisely, you can actually go ahead and have this pay for your lighting controls.
Cool.
Next slide. And of course, there are incentives for improvements in HVAC systems, including rooftop controls and chiller plant upgrades. Next one. And then there's the whole building sort of pay for performance initiative, which is gaining some speed, and the existing building commissioning program. So these are all different ways that that City Light can help, in addition to having things like the Lighting Design Lab and the final slide for that. And there are, in fact, some new construction incentives as well. So I would suggest that we don't have the time or the personnel to go through these right now, but if you go to the final slide of this set, if you go to contact the energy advisors, and apologies, looks like the energyadvisor.gov email at the bottom got cut off a little bit there. But if you Google Seattle City Light Energy Advisor, you'll go to this splash page here. and you'll be able to find out all kinds of information about all of these things, right? And you'll wind up having the ability to contact the energy advisors who can talk to you in great depth about what all of these opportunities are. And I urge you strongly to go ahead and do it, because there are a lot of opportunities to make your projects better with assistance from the utility.
Yeah.
Same if you're in Puget Sound Energy territory, if you're in Snohomish PUD, contact them and see how they can help.
It's amazing how much money gets left on the table that was just there for your project, and so be smart and do it. Hey, thank you, Shaun, and we got some questions queued up.
Katie, do you want to give us?
Yeah, we have lots of questions. I am going to start at the top, which is the oldest questions. Getting back to Jose, he had read an excerpt that any space under 300 square feet requires an occupancy sensor, and this was in relation to asking why I think electrical rooms don't need an aux sensor.
Oh, electrical rooms are specifically exempted. So there's an exception that says if you go back to the beginning of the lighting controls area, then you'll see that overall exemption for them.
Okay, and then we're wondering what category container terminal lighting falls under, I think in relation to allowances.
Are you talking about outside or?
This is outside. Cameria provided a little bit more context. There's huge yard lighting, so wondering what code applies for that.
That would fall under the exterior lighting area requirements. Once again, I've never heard of anybody having a problem with modern fixtures meeting these requirements. It was a challenge maybe 20 years ago.
I think, Duane, the question is, if we look at the individual lighting power allowances that are actually shown for the what is it, 405.2 or 405.5, there's not a very specific annotation for spaces like that. So what he's looking for is, which very specific kind of space that would be under, because there are a lot of spaces that are enumerated, but that's not among them.
Yeah, and that's a really good example of something that is, you're right, is ambiguous in the code. So come talk to us. We'll probably, I think we'll probably treat it just as we would for parking areas.
That's great advice in general, by the way. No matter where you happen to be, no matter what jurisdiction holds sway, if you have questions about any code, reach out to people. Pick up the phone, ask questions. In my experience, most code officials are more than happy to work with you on your projects.
Yeah, people come in, they got an ice skating rink, they got an ambulance loading area, they got, some weird thing, and we'll help them out.
All right, Cameria, I hope I am not butchering your name completely. If that didn't answer your question, go ahead and write in some more context. And so the next question was from Jira. He said he sees the allowance for multifamily went up from 0.37 to 0.42, which is also higher than what's allowed in Washington code. Is there a specific reason for this change?
I think that the multifamily one excludes the dwelling units themselves, so it's a minority of it. But yeah, some of these actually went up. The overall amount of them went down, but this is all based on research that was done through the ASHRAE lighting people.
Okay, and then Dilip, I hope I got your name close, said, so interior lighting power densities and exterior lighting power densities and other control capability requirements are matched up to ASHRAE 90.1 2022 instead of ASHRAE 90.1 2019. Is that correct?
That's right. And so we've updated that reference. Rather than having to wait a whole code cycle to bring in those, if we have standards like that that are available to us in time to do the Washington State Code or the Seattle Code, then we go ahead and take advantage of that, so we stay up to date.
Okay, and I do want to recognize we're right at noon, which is what we kind of told people we'd end. We have several questions to get to. Can both of you stay on past noon?
Yeah, I can. And just for those who have to drop off, just be aware that there's this online survey that is, it will pop up, and please fill them out. City Light finds those to be very valuable, and for programming future stuff. And here's where you can find everything that's going on, and that'll be in slides that are posted. Go ahead.
Yep, and we'll keep this recording going, so all the rest of these will be on the recording too. So Isabel is looking for some advice on applying Washington Code and uniformity ratio for interior lighting design and uniformity ratio for outdoor site lighting design.
Go for it, Shaun.
I'm not entirely clear on what the question is.
I think they're looking for the ratio of the darkest to the lightest areas.
Yeah, no, I get that part, but I'm trying to understand how that applies to energy code. And I'm going to be honest, I'm not following where. I'm not fully following the question beyond as a design standpoint with respect to uniformity ratios following the particular guidance of the Illuminating Engineering Society recommendations. That would be from a uniformity ratio, those would supersede anything in my world that an energy code would bring up.
So I guess the bottom line is look it up in the IES standard.
Okay, and then also she was looking for some advice on dealing with a client who complains about the complexity, quote unquote, of network lighting controls and dependence on manufacturer proprietary engineering services to program the lighting control panel settings.
So the reality is we those of us in the design world anyway, would probably really like to have interoperability, particularly the kind of plug and play interoperability that has allowed things like phones to operate as effectively as they have, or to allow USB standards to be as effective as they can be. Thus far, that kind of standardization has largely eluded the building controls industry. Some standardization within HVAC controls is a little better than within lighting controls, but the reality is that complicated specific task systems at the moment are still complicated specific task systems. So while we would love to have that, your owner is not wrong. I would also love to have simple, easy operability, but the reality is even when you start using base systems like DALI, digitally addressable lighting interface, which is an open source protocol, that is with respect to the lighting controls drivers, right? The LED drivers. The front end systems that are talking to Dolly are largely still going to be, for the most part, proprietary. So hope springs eternal, and the industry knows it has a problem, and the industry is fighting with itself to come up with a solution. Stay tuned.
Yes, that's a common complaint. Then back to credits, the change in credits. Dilip was reading that it was maybe applicable only to envelope, renewable, and elevator credits. The 1 credit equals 6 credits. Is that applicable for lighting as well in this code?
Yeah, there's credits that are assigned for the different lighting things. You saw I circled one that was like, 15 credits, and another was 72 or something like that. So those are all in this on this new system, as well as the total requirement.
All right, and then we have an owner that does not want solar panels on their new building roofs, but is willing to do a ground-mounted solar array. Is there an exception for that?
If it's on the site, that is just as good as being on the roof. And some people actually have been using them as shade canopies for parking areas. That's fine.
Oh, that's a good solution. Okay, so for the next one, it says for metering, what is the approach for a building where multiple tenant spaces share parts of a central HVAC system?
The requirement in the code is for the whole building to be metered. With multiple tenants along the ground floor of a big building, I think that the owner will want to individually meter the different tenants. They are not required to. Some buildings still just basically charge people for their power usage by on a square foot basis. It is certainly advantageous if you get to be a full floor tenant. Then that does require additional, that does require its own sub-metering system. But otherwise, all the HVAC can be on one meter.
All right, one more question from Jose on C405.2.1. Line item 13 states that aux sensor controls are required for service corridors. Does this apply to public corridors as in hospital or office building?
I thought we changed that from, are you talking about the current 2018 code? In any case, I don't have that up right now, but if it says service corridors, then it usually refers to back of house corridors that only staff would use.
Okay, and Jim Lowen, the behind the scenes reminder to me that the incentives for lighting, some of them are going to change after July 1st. I put this in the chat just so that everybody has a reminder. Call the energy advisors when you're starting a project between now and whenever. They'll have the latest rebate amounts and incentive amounts. That's 206-684-3800. And thank you to Jim for reminding me of that. It looks like our questions have all been answered. Lots of thank yous. Reminder that the PowerPoint presentation is still available to download. If you see the little handout section in your GoToWebinar tools right now, as soon as we close, you'll have to wait between 24 hours and a week before I get that up on the website, but it will be available eventually. And yep, no more questions are coming in.
Cool. And you mentioned July 1st, just so everybody, if you hadn't heard, both at the state and the Seattle level, those deadlines have been put off until October. So you have a little breathing room before the 2021 code starts to kick in. So thank you all so much. And we'll see you the next time Katie summons us into the room.
Thank you, everybody. The code series is complete for now. Enjoy your lunches, and we will see you soon.
Thanks, everybody.
Thanks, Shaun.
Thank you, Duane.
Thank you, Shaun. Yep. Thanks, guys.